Hi everyone, we are going to analyze the data we collected today from our Atwood's machine lab. So you can see that on the screen right here, I just have some data collected with an Atwood's machine. There's part 1 and a part 2 like you should have. And then right here, I have my Logger Pro where I'm going to put my data in so I can make the graphs that it's asking for in the post-lab questions. So we can see that when you just open up a new Logger profile, it is just going to default to giving you one data set with an X and a Y. And I'm actually going to need two data sets. I'm going to need a data set for part 1 and I'm going to need a data set for part 2. So the first thing I'm going to do is I'm going to double click on this data set right here. I'm just going to go ahead and say I'm going to use this as my part 1 data set. And I can cut and paste what part 1 actually is. Part 1 is constant mass for me, or constant total mass. So I'm going to paste right in for the comments, constant total mass, and I'm going to say okay. So it gives me part 1. And then I'm going to need another data set. And that other data set we can get by going over to data and saying new data set. And I'm just going to make this right here a little larger so we can see both of our data sets at once. There we go. This data set I am going to want to call part 2, and it's going to default to part 1, 2. And this right here is going to be a constant mass difference. And so I'm going to, right in here, put that's what's going on with my part 2, constant mass difference. And so now I have a data set for part 1 and part 2. And you can see that for my part 1, if we look back into developing the model questions, I want to graph the acceleration against the difference in mass. And so in order to do that, it's going to be pretty simple. I'm going to want acceleration on the y-axis, and I'm going to want difference in mass on the x-axis. And so I'm just going to double click on this x-axis right here, and I'm going to call this difference in mass. And I'm going to give it a short name of delta M. And I think we have a Greek uppercase for that delta, uppercase for that delta right here, and M. And the units in that is going to be grams for me. So I'm going to go ahead and put that in grams and say done. And then I'm going to want on my y-axis acceleration. So I'm just going to double click on that y. I'm going to say that that's acceleration. Like that, and the short name for acceleration I'm going to give is A, and that is going to be in meters per second squared. Superscript squared, awesome. We're going to say done. And now I can just take this data that's in my Google table and I can paste that acceleration data right into the acceleration table right there. And I can take this difference in mass data and I can copy and paste it straight into Logger Pro. Paste, and you can see that it doesn't put anything into this top row right here, and that's not really a big deal because there's nothing in either case and it's just not going to graph anything. So I'm going to go ahead and make this graph just a little bit smaller so it's easier for us to see. Oops, not all of Logger Pro though. I'm going to make this graph just a little bit smaller just so I can see it in comparison to my table. There we go. And you can see that I'm getting a pretty straight line through the origin, which is what I expected on my, here we go, on my pre-lab that we did. And the other thing that we want to talk about is the slope with this. And so because this is a straight line through the origin, we can just do a linear fit. If we go up to the top and you mouse over linear fit, it's going to tell you what it does. You can click on that, and it's just going to give you a nice linear fit with a slope in meters per second per gram. Now, when you're doing this yourself, you're really going to want this slope to mean something. So you're going to ask yourself, do you really want this in grams or kilograms? And you might need to do a little bit of converting with what you guys put in here. And so that gives me a nice graph for part 1. And if you are making your graphs in Logger Pro, which I'm assuming if you're watching this is what you're doing, you might want to be able to put a title on that graph. And it's pretty simple to put a title on a Logger Pro graph. You can double click on it. You can go over to graph options, and we can just say that this is a constant total mass, part 1. And we can really just take the title right from our table and put it right onto our graph. Say, okay, now you've got a nice title on that graph. Now what we can do is we can take our data from part 2 and put it into here. So we're still going to want acceleration on the y-axis for part 2. So I'm going to just double click on that y-axis again and say that it's acceleration. I'm going to have a short name of A, and my units is meters per second squared. And that's a superscript 2. I'm going to say done, and you can see I have acceleration. But now for part 2, I'm actually keeping the mass difference constant. For me, it's 50. It's going to be different for you guys. And my total mass is the thing that I'm changing. So I'm going to come over here, and I'm going to call this X total mass, or mass total. And I'll go ahead and give that a short name of just M, because it is just the total mass. And I'm going to have that in grams because that's what I measured it in. As you're doing this at home, you might want to think about whether or not you want this in grams or kilograms. So I'm going to take my total mass right from here. I'm going to copy it. I'm going to paste it right into Logger Pro. And I'm going to do the exact same thing with my acceleration. I'm going to copy this, and I'm going to paste it right into Logger Pro. Now you can see that this graph that we made right here is still pulling the data from part 1. We really need to make another graph that's pulling data from part 2. And we can do that by just inserting another graph. And if we look at this, it's going to just give us an exact copy of the graph that we already have, which really isn't what we want. So what you're going to want to do is just double click on this graph so it brings up your axes options. And can you see that we're still pulling data from part 1 right here? You're going to want to stop pulling data from part 1. And in your y-axis, what you want to do is be graphing the acceleration from part 2, because this is part 2 data, right? And so I'm just going to, you can see the acceleration is clicked right there. And the difference in mass isn't what I want. You can see in part 2, I want to have on my x-axis mass total right here. And I'm going to want to auto scale this from 0. So because I'm here, just because the origin is something important to see, I'm going to go ahead and click both of these as an auto scale from 0. I'm going to say go ahead and graph that. And you can see that we get that inverse relationship approaching 0 that we expected to get in the pre-lab. But remember, the other thing we talked about in the pre-lab is what I really want in this lab is a straight line that I can see what the slope is. So we can really linearize this graph. And in order to do that, I can't just graph the total mass on the x-axis. I need to graph what's proportional to acceleration. And acceleration is proportional to 1 over the total mass, or the inverse. So what I need to do is have a column that really equals 1 over the total mass. And in order to do that, I can just go to this data and make what's called a calculated column. And my calculated column is going to be the inverse of mass, or short name, it's 1 divided by the mass. The units that this is going to be is grams to the -1. It's really the inverse of the units that we were talking about before. And what I'm going to need to do is make sure I'm pulling this from data set from part 2, because remember, this is dealing with everything going on in part 2. So I really just want to make an expression or an equation that will calculate 1 over the mass. So I'm just going to do 1 divided by, and then I'm going to choose the variable mass total. I want to do 1 over the total mass, and I'm going to say done. And do you see that in part 2, another column appeared right here? And this column is 1 over the total mass that we have right here. And so what I can do is now, instead of graphing the acceleration against the total mass, I can graph the acceleration against 1 over the mass. And to change that, all I need to do is come down here and choose inverse of the mass for my x-axis. And we can come over here and just kind of drag this axis so that we can see that last data point right up here. But do you see we really do get something that looks very much like a straight line through the origin when we graph the acceleration against the inverse of mass? And we can do the same thing we did up here. We can come up to, make sure we have this highlighted, come up here, and we can do the linear fit for that. So that should be everything that you guys need to analyze your data. Please come and ask questions if you have any.